So I express this speed in kilometers per hour. 1.25 meters over 1 second in kilometers per hour. So 1.25 meters in terms of kilometers. 1.25 over 1000. Then 1 second in terms of hour, 3600. Because 60 times 60 you get 3600. And then just use your calculator to work that out. 1.25 divided by 1000. Then 4.5 kilometers per hour. Next, maximum speed of a leopard. Wow, really? Yeah, it sounds like it should be a cheetah, right? Okay, so 120 kilometers per hour in terms of meters per second. So 120,000 and 3600. So that gives us 33 and 1/3 meters per second. Faster than a car? I'm sure most cars can go faster than 120 kilometers per hour. Huh? It's just that the speed limit will be 90 kilometers per hour lah. You don't give excuses, huh? Okay, next. MRT travels 160 kilometers, average speed 96 kilometers per hour. How long did the journey take? So if you need your triangle, draw it DST. So time will be our distance over the speed. So you get 5/3 of an hour, which is 1 2/3 hour, which gives us 1 hour 40 minutes. Okay, next one. A lorry takes 25 minutes, travel 30 kilometers. Find the average speed, kilometers per hour. Speed, distance, 30 kilometers over the time, 25 minutes. You want to change that to hours. 25 over 60 of an hour. So you get 72 kilometers per hour. Okay, this was done. Now question 10, that was also a homework question. So Jimmy started his journey very early, 7:30. A to B, 36 kilometers about average speed. Stop for 45 minutes rest. Okay, so I want you to highlight this part. Stop for 45-minute rest. Without even reading the rest of the question, most likely they are going to be testing you on average speed. Why would they be asking? Well, why would they be telling you about somebody resting 45 minutes? They're not moving, because they are trying to see, like the example that I gave you in class, whether you will account for this 45 minutes as part of the total time taken for average speed. Okay, that is the only reason why they will put that in. So he continued his journey at another average speed, arrived in town C 1.5 hours later, calculate the time he arrived in town B. So time in B will be 0730 plus the time taken for the journey. So we know that DST, we know the distance, we know the speed, we can find the time using distance divided by speed. So 36 over 48. Okay, this 36 over 48 will be in terms of hours. So that is 45 minutes over there. 3/4 of an hour, 45 minutes. So we get 0815. This is the time of arrival in town B. Then find the distance between town B and C. So remember, when he arrived at town B, then he stopped for a rest, then he continued to town C. He arrived 1.5 hours later. So using the same triangle, we can find the formula for distance, which is your speed times the time. So the speed being 54 times the time, 3/2. You get 81 kilometers. And now find the average speed. Very sneaky, the way that this question is phrased. You are given the first speed, you are given the second speed. So that is a trap for you also, to see whether you take the average speed as just adding up these two and dividing by 2. Then that will be wrong already. So the other error will be total speed divided by total distance divided by total time, but your total time doesn't include 45 minutes, so that will also be wrong. Therefore, we need to really use the formula average speed total distance over total time. You do not need to write this down, but I'm writing it down to remind you that total distance literally means the total distance traveled. Total time literally means total time taken, including of whatever breaks he took. So total distance in this case, 36 kilometers plus 81 kilometers. This is in kilometers. Numerator in kilometers. Now denominator. The time taken for the first part of the journey was 3/4 of an hour. I'm writing 3/4 instead of 45 minutes because I want the final answer to be in terms of kilometers per hour. So he took a break, another 45 minutes, so another 3/4 of an hour. And the last part, he took another 1.5 hours later, so 3/2. This answer, this working over here will produce an answer in terms of kilometers per hour. So 3/4 plus 3/4 plus 1.5, that's the denominator will be 3. 36 plus 81 divided by 3. You get 39 kilometers per hour. Why so slow? Why is it so slow? Look, his average speed was 48 kilometers per hour as well as 54 kilometers per hour. How come the average speed ended up being so slow?
55 minutes.
There was a 45-minute break. That's why his average speed was very slow. Okay, next one. A van traveled at an average speed of 72 kilometers per hour from the airport. So we've got one place, that is the airport. 20 minutes later, a car started from the airport, drove along the same route as the van. Then the car caught up with the van after traveling a distance of 78 kilometers. Find the average speed of the car. Okay, first, do you understand the situation? Anybody doesn't understand the situation? Can visualize what's happening? Okay, so both started from the airport. The van started traveling first, 72 kilometers per hour. 20 minutes later, then a car started from the same starting point, drove the same route. After traveling 78 kilometers, then he caught up with the van. So find the average speed of the car. Okay, try this question now. Okay, now class. Take a look at this. 20 minutes later, a car started, drove same road, and caught up 78 kilometers. When the car caught up, the van traveled 78 kilometers as well. So based on this, when car caught up, van traveled 78 kilometers as well. Okay, you don't have to copy this down, but you can if you want to, so that you understand what is happening when you are revising. When the car caught up, the van traveled 78 kilometers. So using the speed and the distance, we can find the time taken. We can find the time taken for the van to travel this 78 kilometers. So same thing, DST, time will be distance divided by speed. 78 divided by the speed. And you get 13 over 12 hours. So the van has already traveled for 1 hour and 1/12 of an hour. That is 1 hour and 5 minutes. Okay? 1 hour 5 minutes later, the car caught up with the van.
Yeah, the van, the van.
1 hour 5 minutes later, car later, later, car caught up. So that's what's happening over here. And the car started 20 minutes after the van. This implies that the car traveled for 1 hour 5 minutes minus 20 minutes. Okay, so that will be 65 minus 20, 45 minutes. The car traveled for 45 minutes. So we want to find the average speed of the car. Car's speed will be our distance divided by the time. How far did the car travel? 78. What is the time taken? 45 minutes. So in terms of hours, that will be 3/4. So 78 times 4 divided by 3, you get 104. So this presentation shows clearly what is happening. This presentation shows the marker, how you did it, and what is going through your brain. But if your working just consists of fractions, subtracting fractions, conversions here and there, without explanation, and yet you get the same 104, you still will not get the full marks because to understand what you're doing. Okay, that was what I observed as I was walking down. At least 2 papers, correct answer, but don't know what you're doing. You know what you're doing is not good enough. You have to let me know what you're doing. And that means your presentation must be clear. Something like this. Next one. O-level questions. Calculate the time it takes a bullet to... What? Oh, calculate the time it takes a bullet to travel 100 meters at the speed of blah blah blah, give a time in seconds. So part A, DST, so time equals to distance divided by the speed. 100 divided by 5,000. .02 seconds. Part B, average speed 450 cm in 1.5 minutes. B, speed, distance 450 cm out of 1.5 minutes. Give our times in meters per second. So this in meter, 4.5 meters. In seconds, 90 seconds. .05 meters per second. Next, light takes 2 1/3 minutes to travel from Mars to Earth. The speed of light, 300,000 kilometers per second. Calculate the distance. So distance, DST, distance, speed, 300,000 times the time. So 2 1/3 times 60. Because our speed was in seconds. So change this to seconds. Four, 2, 1, 2, 3, 1, 2, 3.
Wow.
Okay? Very far away.
Let's shift to the right a little. Yeah.
Okay, next one. John and Peter, they took part in a marathon race. They each ran 42 kilometers. So John ran at a constant speed, x per hour. Write down an expression in terms of x for the number of hours that he took. Is this the last one? Oh, okay. Time, distance, 42, divided by the speed. Okay, so this is for part A. This is another popular type of question where they do not give you the actual speed, they give you x. So you have to be comfortable with using algebra, just put it inside. And that is the answer. So this is the number of hours that John took. And then we have Peter. Peter, he ran at a constant speed, which was half a kilometer per hour less. So Peter's speed is x minus half. This is Peter's speed. So write down an expression in terms of x for the time that he took. So time is the same distance, 42, divided by x minus half. And this will be in hours again.